Really excited to be able to kick this off with co-sponsorship from the Center for Digital Strategy. And last night we had a really good event with the FinTech Club and the Tuck Energy Club, and so and carried it on to dinner for a lot of really compelling discussion and talking about some of the cutting issues, which really have no sort of clear answer. But we're all, I think we left yesterday feeling like we're just barely scratching the surface on understanding a lot of this. And so really excited to have Frank Curran here as the co-founder and vice president for the CleanEnergyBlockchain network, which focuses on clean energy peer-to-peer blockchain. They're a North American partner for Power Ledger and IBM blockchain. Frank has a long history as an entrepreneur, working in operations, and he's worked a lot in the tech space. And so we were, I think, sharing, ideas and concepts on both sides of the house. And really excited. I want to turn it over to Frank to give a little bit more about his background and get us kicked off in learning about blockchain and clean energy applications. So thank you, Frank.
Thanks, April. Thank you, everybody, for coming and participating. Can you hear me okay? Everybody good? Great, okay. So I'm going to break the 10-slide rule, only because there's a lot of information based on yesterday. So I'm going to put up a few slides. You're all going to actually have access to them. So I'm going to skip through a few where you might want to see a lot of detail, but we can talk through it. So I'm going to start with the agenda, I hope. There we go. So what we're talking about today was really about who's CleanEnergyBlockchain, what's the analyst and market saying about us, the blockchain world, what is blockchain, and I'm going to give you some of our use cases that we're working on to help you understand. So I'm going to go into a little bit of a question. So how many of you do farm to table? You don't count anymore because you already know the answer. All right, up here. Okay. Why do you do farm to table? Those of you that do it. Go ahead, Melanie.
Because it's local.
Okay.
Support local.
Okay.
Yeah, I mean, supporting local farmers for the most part. Better food.
Okay. Back. Same. So some people are doing farm to table for the local part, but also, you're trucking in those fruits and vegetables, you're trucking in that fish, so you're reducing the carbon footprint, right? So you don't have to do that. One of the questions I'm going to have through this process, and I want to ask you at the end if you change, I think we can take the concept of farm to table and make it farm to table energy, right? So farm to table for energy. So think about that as we go through the discussion, and I'm going to tell you a little bit why I believe this. So we're going to move on. So the team, so I'm one of 3 founders. Person on the left, Mark, you're right, I'm sorry. The person on the right is Mark Johnson. Mark's a 20-year veteran from IBM Utilities. He then worked at DOE for a couple of years, and then he was at Schneider Electric Microgrids. The person in the middle is Mike Ashley. He's a PhD student at Northwestern. Mark was a mentor to Mike. He's a recent graduate in material science. And then, of course, I'm on the left there. Open source guy. I've done 5 or 6 startups, 1 big company in various places. You guys have my bio. You can look me up on LinkedIn. The key that I want to bring up in what I'm showing here is that we get confused a lot with blockchain, where people like LL3 who have a piece of hardware and it's proprietary comes out. We also get confused, is it cloud, not cloud in the model. So, and also when people look at what blockchain's doing, it's energy intensive. They think we're taking up the energy of the whole state of Rhode Island. So 1, we're non-proprietary hardware. We're an open source software. For technical people, we grab the data behind the meter and pull it into the cloud, so it's a SaaS model. And we do work with the utility, so we do share pricing with them. And we're not a proof of work, and I'll talk a little bit more about what that means in a second. At a high level, what's going on in the macro view, and I just had this conversation upstairs with the digital group, and really what we're looking at here on the left is what's happening with artificial intelligence, blockchain, and when you look at what's going on between robotics and how do you bring that together with the energy field, there's that mix. So when some people are looking at future ideas and concepts. I think artificial intelligence is going to be really big. But now you're bringing in the other side where you have distributed energy, you have the sensors. And we haven't got to the IoT piece really within the blockchain, but you can see how Alexa and Nest are going to come in to say, my energy is going so far, I'm going so fast, I'm going to be gone for a day. Alexa, turn my energy on and off, right? And I will do a prediction. I think Amazon and Walmart are going to be energy companies of the future based on this. If you think about what they're trying to do, I really see that as a happening opportunity. So what's happening in this transactive energy? How it started was net metering. So in one way, what happens is energy was coming in, and how do you get rid of your excess energy? It came a way of incentivizing people, so you were allowed to dump the energy back, and they give you a certain price. But it's billed at the end of the cycle, so it's not real time, and now you're not really getting the way to send it back and get a better price, right? You negotiate for 9 cents, and that's all you get. You know, you don't get it back at maybe peak load where you should be getting 21 cents. On the right-hand side, you have what's happening with RECs and credits, and if you watch the news, I think today, Facebook and Microsoft did another 400 megawatts combined. So people are buying energy outside. Some are doing it close to their buildings, but most people are doing offsets. So they'll buy a REC and say, hey, because I'm using this energy, I'm going to put this back so we can do planting trees and deforestation and things like that. So these are some of the bigger companies, Google, Shell, everybody's doing this. But it also is part of where the movement's going to shift, right? Because one of the things that I'm worried about and people are talking about is when some of these big companies buy local in North Dakota, but their business is here, sometimes you have to look at the economy, and is that going to affect the economy if they have a 50 megawatt wind farm and 100% is going to Google, and it's in South Dakota? What happens to the energy for those people that live in that area, right? Does the energy price go up? Because you would hope that that farm would support local, right? Remember my farm-to-table local. It's not. So people are wondering how that's going to affect the business. And these companies, Walmart and Shell and others, are really being conscious about that. But I think as we get more people buying, it's something we have to watch. And you are the ones that should be watching it. So this is a busy slide. I only put this up is, real quick, when people ask me, well, can you really do blockchain in the utility space? If you look at the purple, that's the consultant, and he went out and spoke to all 10 large ISOs, so ISO New England, PGM and all that, and the 5 utilities in New York. So that's where he is. So look at all the disruption from enterprise management, right, supply chain technology. Look at where you are in the markets integration, and if you look at some of the other areas where it's data and demand, right? And that's purple. Light blue he thinks is really going to happen. I actually disagree with some of the ones that he doesn't think are going to happen, because regulatory, if you go back to the REC piece, which I just said, people are filing their 10Ks and putting in their sustainability. How do you prove that you're really doing what you're doing, right? You got to 20, you got to 0%, you got to your 2030 carbon climate goals. How do you prove it? So at a high level, you can see really there is a lot of opportunity. So those of you who asked, is there an opportunity for me in the energy space and using blockchain? Pick an app. You can pick one of those segments. So what's also happening is most of the energy starts with generation, right? Big power plants doing it, the coal plants, and then it goes down to the transmission, and then you get to the local users, right? It's one way, top to bottom. What's happening now is you have a hub in the middle, which is transmission now. And transmission is a vehicle for all the other people around the sides, whether it's solar to a building, whether it's EV charging to storage, whether it's commercial to a business, residential to commercial. So now you're having a different type of ecosystem, and you're also having customer choice. And this is what's really driving. For those people who want, I want my solar, I want green energy, I want to buy it, I want to know I have it, I want to know that the utility's thinking of me. The utility is 150 years old. We're breaking the model. Most of the utilities do not know their customers, right? When they aggregate the data up, it's usually at a regional level or a state level. So now if you get behind the meter, you're doing the Alexa thing or the Nest, or if you look at what happened with Green Mountain, when the sun came a few weeks ago, it was really hot, they saved $580,000 because they were able to take over the storage and their meters, right? Those are the things that are happening with these type of business models, and it's customer choice. I'm allowing them to take over my power, and then because of that, I get the benefit of new and different energy. So I talk about the physical to the digital world, and really, blockchain is not new. It's really old. So if you think of taking a dollar bill, right, something physical, you take your debit card and you put it in an ATM or you put it in a vending machine, you put that in. Does the dollar bill know? Does the machine know it's a dollar, a $5 bill, or $10 bill, right? It's the synthesis of the digital part. And it's the same thing. I can be in Switzerland and my bank here is in Boston. I put my debit card in, green stuff comes out, I'm happy. How does that process work? Cross-nodal, digital, then it gives me from a physical perspective to a digital perspective. That's how I can do my transactions. If you look at the dartmouth.edu, what I'm trying to show there is if you're working on a Word document and you're in Switzerland, you're working on a project, you come back and you send it back here to one of the professors, you're sending through the internet. And this is where people are talking about how blockchain is going to change the way the internet works. Is this principle, you're not really sending a Word document, you're sending code across HTTP, right, S, and secure, internet protocol. And that's been around for years. And that's the same principle when you do the transactions of blockchain. And I'll show you that in a second. So, blockchain, what is it? So, blockchain is a distributed ledger. It's just like a bank ledger or an accounting system. And basically what happens is you're able to take that ledger not only from a financial transaction perspective, but also data, content, things like that. And you take that and you request it into the computer. So the green squares you're seeing in the circles are distributed computers, right? Again, think of all of us working all around the world, and we send out that Word document. It goes out, it pings the systems say yes, it approves it, moves it into a process of verification, which is the checkbox. Each box has to be checked. So if there are 20 of us and 20 computer distributed systems, all 20 have to agree that this information is already there, it approves it, and adds a new block. So what has to happen is if the transaction says, April wants to sell me energy at 9 cents a kilowatt hour, and I want to buy it, we have to agree that the contract's there, and if April already has an existing contract, and she has it for 9 cents, and she only has so much power, she can't sell it to Patrick. The verification process will come up and say, either April doesn't have an agreement with Patrick, or April has already sold that energy to me, and therefore that contract is null and void, and it won't allow it to happen and build a block. So that's blockchain. The other way to think about it real quick, and I did it today, was all of us are here, Google Docs. I'm the author, I allowed read and write. All of us are here, we're working on a project, you're writing away for 20 minutes, I say, okay, everybody's done. I'll lock it down, right, and make it read only. Everybody that did anything on that Google Doc, you can all see it, correct? Yes, right? We can all see it. That's the same principle. You lock it down, and now that has a life cycle. And you timestamp and you date it, and now it goes off. So that principle, if you can grasp that one, that's another way to look at blockchain. There are 3 types of blockchains. I'm not going to go too deep, but the first one is the public one. That's the one that Bitcoin came from. There's no human interaction. That is totally computers, and that's a problem with proof of work. You have to go out, and all those millions of computers in blockchain, because there are 500 million of them, all have to do that consensus and agreement. So that's one of the problems why consortiums came up and corporations came to a permissible or consortium blockchain. And so those could be the one where it describes the 15 different financial services companies coming together. Consensus, instead of everybody having it, 10 different groups at different times are allocated. They have to verify it. If the 10 don't agree, it doesn't happen. And part of that is to prevent fraud, right? So that's one. The other is a private one where you may have a certain amount of information and you want to make it private, but still make some information available through some transparency. So those are the three that you'll hear about. A lot of people are doing the private and the public, a hybrid, and that's what Power Ledger does. That's what we do in one of our models. To me, this is the biggest key to the whole blockchain process. And it's really about taking a smart contract, if you use the Word document analogy that I showed you, and it's about time stamping and adding the data. So what happens is the contract comes in, and if you think of energy, those of you on the energy side, if you can know that the meter information comes out, I know exactly it came from an EV versus a building which has mixed energy, I can say that is from April's energy, from her EV, and oh, by the way, I want to sell it, and therefore I can get the green credits versus mixed use. It's been time-stamped, it's been dated, and now it's all the way through the process of a life cycle. And so that's that process of taking out the middleman, because you don't need a contract. April and I have decided we're going to do it for 9 cents. This is where the middleman of lawyers and finance people, and that's why VCs are all upset about this, and now they're trying to get into it, because you're taking out some of those middlemen, and it's real-time settlement. So if you think of the accounting process and doing real-time billing, real-time settlement, I can get paid in less than a minute versus taking the time in other traditional models of 30 days and 40 days. So it's changing the credit balance of some of these small companies that have to hold that. To me, this is the key. Real quick, what you're having now is platforms. And on the bottom is the blockchain, as we talked about. What's that enabling is the application layer. So one of the applications is peer-to-peer trading, and I've been talking about April and I trading on the 9 cents. This is where you can get those transactions. It doesn't have to be for money. It could be for paintings. It could be for any data. It could be for your land ownership, all sorts of different things. This is what's allowing us to do that trade and that application. It's a very key component of it. The other part is really about the ability to do the transactions and what's happening in the energy space from a transactive energy. You're allowing efficiency. You're allowing for the people to be able to do the trades, right? And that's going to make the transactive energy when we bring EV charging together, storage together. So as you look at the platform where the technology is the blockchain, the application is peer-to-peer, and then now you can have multiple ways of an ecosystem to work together. Again, real quick slide. I don't want to spend a lot of time on this, but this is really about when you see the red, this is how the energy management system works, and then you have the renewables down to the right, the blue. And the idea is really that we're able to do a lot of work in making sure that we can manage it real time. Again, that's the key, right? We want to get paid. We want to see what's happening real time. And we also can do it from settlements, and you can do the monitoring. So that's really what I want to try to show on this part, is it's situational awareness. And if you look at the situational awareness, now you can go back to artificial intelligence, right? Because we can say, hey, what's going on, or IoT? And that's going to change business models. This is all about business models, too. So I really want to show 3 or 4 case studies. And this one was 46 EV chargers in Santa Clara in a building. And we were going to do peer-to-peer trading. One of the issues they were trying to deal with was carbon credits, because in a building you have the EV charger, you have solar on the roof, you have the developer. Who gets the credit for building that energy? And that is worth $50 per credit usually in California at different times. So when we were talking to them about remember the timestamp, we could actually tell them, we know it's coming from EV, we know it's coming from solar, or we know it's coming from storage, or we know it's coming from dirty, just the main feed. And when they said that, they said, wait, well, we have a process that's an Excel process. So normally, the EV charger or the developer would say, hey, this car came in, took the 5 kilowatt hours worth of charge, and it was worth X, and they put it on an Excel spreadsheet. hundreds of thousands of these, hundreds of thousands of rows. And they settle it up in 90 days. Some of it, when they do this, when they look for the buildings, when they verify some of this, they go on Google Maps to find the building, find the mapping, see if there's solar on the roof. So they use that type of GIS capability. Very long process, very tedious. We were able to take the meter data, and that's what we're doing right now, straight from either EV or solar, and decide who can get that credit. So we're taking it from a 90-day process to instantaneous almost. So that's one. The second one, this is solar storage EV charging. We're working with Evanston, Illinois, and we're putting this combination into a parking lot. And they're going to do some trading and energy management, but the real cool part about this is any excess energy, we're actually going to send to 2 low-income housing projects. So it's a community coming together. It's us coming together. We're not going to take our trading. So how we normally make money is if the 9 cents kilowatt hour trading with April, we may take a half a cent, and then the utility will take a couple pennies on top of that to do the trade. We're not taking anything, and we think we've got the utility not taking anything either. When you think about the fixed income or the peak loads in the winter and the summer, right, when it gets really hot, air conditioning is going, or when it gets really cold, our fixed income seniors and our low-income housing are struggling. And we're going to broach this in a couple other places. You'll see a few more of these projects that we'll do. But we're really excited about this project. And I have to give April credit, because April and I were talking about this for 9 months. Wouldn't it be cool if we could do something? And I actually kind of leveraged our conversation in this model. So kudos to April for talking about it. We kind of had the idea, but not to that model of from the town and working with the town back and forth with the college. This is kind of the traditional peer-to-peer. We kind of use that 9 cents. But really what you see is there's a prosumer on the side who wants to sell excess, the blue panel. And typically you go through the utility and they may charge you one rate. But the condominium owner on the right says, hey, I'd rather get my other local businesses the money. So they'll pay a certain fee, and then that's where you see the transaction go back at a certain price. A fee goes to the utility for transmission, because we're working with them. A fee would go to us, and you clear it. The thing is that because of the business models, we're learning different timing, and so peak loads and pricing. If some of these companies are looking at saving money, you can do it this way. Some people are so looking at their 2030 carbon footprint that if it's equal, it'll help them as well. But this is a model that, the peer-to-peer model that I was describing before. And I'll just skip that. This is one that's close, near and dear to a couple of our hearts here, why I'm up here too. So Northwestern has excess energy on a couple buildings. And because the college dorm is not that busy on the weekend, some of the buildings are not being used during break or the winter sessions, they want to transfer intercampus, so one building to another, one of the student centers. So they're going to do that. But really what we started doing is, our motto is learn by doing, right? This is all new. We're kind of pioneering it in the Northeast, I'm sorry, in North America. So we're kind of the first ones really out. And what we're doing is we're working with the Northeastern University, various businesses. So we're working with the master's and MBA program, and they're helping us with doing a monthly report. So every report we do on the generation, what we're trying to look at for optimization, they're working with us. We're working with the mechanical and computer science department, who are looking at putting EV out, and so they're going to start looking at how do we optimize this. They may even clean it. They may work on it from a different perspective. And then we're working with some of the other groups in looking at predictive analytics and AI. So we're going to now start taking some of the residual data from the last 2 years and pull that in and look at some ways to look at predictive analytics for this. So we're doing this at UMass Lowell. We're doing it a couple other places. And my hope is we do it here. So that's one of the goals, why I'm up here. So I'm back to my slide. So after my conversation, do you think we can do farm to table for energy? Raise your hand if you think we can do farm to table for energy. Cool. That's a first. Nice. I'm excited about this. Really, you know, back to why you're doing it, right? It's the local economy. And it was 4 months in, and I was talking about this. I said, I really feel passionate about, as much as we want to save, you know, the world and we want to save, you know, the power line and all that, it's local, it's a network. We can control this, right? It's our neighborhood, it's our choice. It's very hard to control what's going on in Pennsylvania and New York. But I think it also bridges the economy. It makes us cleaner. We can do as much as we did for LEDs. So I have a passion for this. You're going to hear me scream from the top of my lungs, farm to table for energy for all of us. So that's a key point. I'm glad you all agree. I'm excited about that. So we'll go to questions. My information is there. Feel free to email me if you want to call me. Just come down and grab my card. I know I went through a lot, but I want to open it up for questions, comments, and go from there. So please, feel free to raise your hand. And if you want me to go back to a slide, let me know, and I'll zip back there. So who has questions? Yes, in the back.
So this might seem like a ridiculous question, but could you just explain why you actually need a blockchain to like do this versus like a different technology that might be?
Great question. Great question. So if you go from comparing to a database to blockchain is usually one of the biggest ones. So I'll start with that. So the database, you have columns and rows, and there's certain queries. If you think of the distributed model that this has, right, multi-nodes, multi-groups, most database, one database administrator per database. You have to set up the queues. You have to go through the process of asking, right, to write the reports and do different things. After a while, you get them automated, but a traditional database isn't really set up well for transactions. So I'm talking about 1 or 2, you know, transactions with trading with April. You're going to do hundreds of thousands. It's not set up that way because the blockchain has the application layer, and it can do it from a node perspective. It'll be able to do it a lot faster. The other is it's about more that network effect. So it's doing supply chain. It's multiple users. So although we're doing April one-to-one, we might be doing Dartmouth. We might be doing the Hanover Inn. We might do. So when you get into the blockchain, it's a bigger group. And so when you have more users, the network effect, it's better applied on the blockchain, multi-node faster than central database. So think more central database versus distributed models. And there are distributed, you know, NoSQL types of databases and things of that, but they're not scaling to the point where this is scaling. So that's part of it. The other is if you get into the reason it started really was about transparency. So remember the Google Docs story, right? We can all see. In the supply chain model, Walmart just did this with food. 2 years ago, they had a voluntary program where they could see where their supply chain was. And you may have heard of the avocado chase and the salmonella from lettuce. The lettuce one, it was out for weeks. Thousands of people got sick. A few people died, I think. They went back and used the blockchain. It took them 4 days. It took 4 weeks, almost 4 months, to find the salmonella problem. So when you have that distributed network, you can see more of the information. It's open to everybody, like Google Docs. You can't do that in the database, right? You have to have certain, you know, knowledge of the database and how to structure it and all of that. So those are some of the reasons why people use blockchain. There's still a lot of debate about it, but I mean, blockchain's been around for a while. Those of you technical that know virtualization, right? This is another way of virtualizing, right? So way back when the computer started, you had an application, a database, an operating system, right? One-to-one. Virtualization came. Virtualization allowed you to abstract the layer of the operating system and the hardware to the software. It went 1-to-4. And those of you who know containers now, it's one operating system, one database, all abstracted to the network layer, and the container layer is the computer side. That's thousands. So it's the same thing in spreading out the nodes, that model. But it was a great question. You get it a lot. I covered it more last night. I was like going back and forth. Sure. Anybody else? Yeah?
I have a question regarding to the entry barrier of the blockchain. So it's more like blockchain. So I'm just wondering for, because like for blockchain, we have to get a lot of nodes and they are computers, right? So just wondering for the cost of those computers. computer, are they a lot lower compared to the like super server for database?
Yeah, great question. It is, because a lot of it you're running kind of the SaaS model, right? So a lot of it's, you know, computer nodes in the cloud. Where it got expensive is where Bitcoin went, right? So Bitcoin is not cheap because they're using high performance computers and a lot of the graphic GUI type programs, and that's why they're all trying to go to the hydro. You'll see them in South America, and that's why they're all trying to go to Quebec. But in this model, it's a good question. I shouldn't probably say this in a college, but I know at MIT and a few others, people were running on their laptops in their college dorms. So they'd set up 4 laptops and start mining. So it's not high performance from that perspective. You'll get some latency, and that's why if you can use the cloud and do the if you're excited, if you have to do the transactions, you want, you know, the computers for that transaction layer. But if you're doing asset management, and, you know, hey, I want to make sure that my birth certificate is my birth certificate, and my passport is my passport, and all of that, and you're just holding it as a record, but you can check it, then you don't need as much computer power. Yeah. Who's got another question? Anybody?
What about the setup cost for like local utilities? In order to do the farm table idea, do they have any setup costs that they need to incur for this? They can distribute more locally. And
that's a great question. So what we're finding is it depends if, so in 2 cases we had to have the companies, the college and another company, buy a smart meter, because a lot of, you'd be surprised, I was totally shocked. I mean, I don't have a smart meter in Stowe, right? So it was $1,500, they got it. We could take it daily, but the idea that you could do it more, you know, every 5 minutes, and it was $1,500, we put it on there. So that was the setup. Some of it is the configuration the first time, but it's pretty easy. Once we figure out what they're looking for from a data structure, and if it's doing kind of carbon credits, we structure that way. Other than that, it's pinging the system and we pull it right to the cloud and the structure's there. So the cost is doing the transactions, which they're doing already. So there's no hardware, there's no software. That's why the no hardware and that. If, for example, we'll have to work with utilities, so sometimes we've done special tariffs. So we've got National Grid to say, hey, will you do something different for this group? The one where I brought up in Illinois, right, where we're asking them right now, hey, will you forfeit that 2 cents? That's where we'll work with the utility to change the business model. So those could be things. We work with all the utilities. We also work with escrows and retail sellers. So depending on who the utility is doing, or if it's a utility, we're working with the utility right now. They're foregoing some fees to customers to try to test some things. So it really depends, but it's a great question. You know, it's part of that. What's the goal? What are we trying to test? What are we trying to do? So did that answer the question? Anybody else? Yeah.
This is where I get lost. So traditionally, you've got an ISO and a bunch of utilities. The utilities are pulling power from ISO, and they're working on meters that both agree on and figure out their billing. Now you insert for one of the utilities this peer-to-peer, which can be using energy among the various members of the peer-to-peer, or pulling energy from the traditional model, or putting energy back in. I don't understand how ISO and the utility figure out what's going on from a billing process.
From a billing process, okay. Yeah.
How do they know that the information coming out of the, I'll call it the peer-to-peer group, is information that they can trust, so they can figure out what one knows the other?
Yeah, great. So that's part of the reason why some blockchain companies are in fights, because they're not working with the utility. Basically, they're putting smart meters on, and they want to become the utility. They want to control that data. In our case, we're working with the utility, so they know, right? But there are cases where some people are going in and putting an inverter and saying, we're going to do the peer-to-peer, and we're going to sell the energy, and they're trying to become retailers, right? So there's utilities who sell. There's hundreds of thousands of little people selling energy as well. So, or municipalities, for example, for another reason, right? So the municipalities. So as long as someone is reporting up, right? So it goes, traditionally, it could be a retailer to a utility, utility to a state before it gets to the ISO, NEPOL or anything. So you go to the state, then it goes to ISO. So there's various stages. When you look at the process where I talked about that carbon credit process where we're working in California with California Resource Board, right? So I talked about the EV charging and then the Silicon Valley Power, solar, and the building, right? And the credit rec, you're describing their problem. They're struggling because people are double selling those recs. People are also, they're using the end of life because they can't track it because it's Excel spreadsheet. Or in some cases, it could be a development, right? So you have a pizza shop, you have an automotive shop, and a gas station. Pizza shop closes. They don't tell the utility. But they've got the recs, right? They've been approved for recs. That's money on the table that's lost because they never went back to the utility and told them. Because we know those 3 meters and we know what's going on, it can be associated to the meter, from the meter to who owns it. So we're actually helping them. And the reason utilities are working with us is, in some of these cases, they want to know the data. They want to know their customer. So because we're pulling the information, we're able to help them do demand pricing and demand response. And because they're part of it, they're getting that information. But it's a very good question because there are some people that are trying to be the intermediary.
You've added another level of complexity to the model that I was struggling to
Oh, I'm sorry.
Well, no, it's fascinating. But the ISO is selling to the utility at month-end rates, I'll call them.
Yeah, sure.
Rates. And now you're inserting another group that are really interested in real-time rates.
Yeah, but we're no different than someone doing the dump and the PPA, right? That person that does the dump, right, has a PPA. They're selling it and they're recording it. We're just another, technically we could be another layer, or we could just be another credit type, arrangement. But more, I would think more like a PPA for a dump, right? There's a financier who owns it. It's a municipality or someone else, right? The municipality doesn't own it. It's someone else. You just get the rate back, but you pay a nice, gracious PPA for a certain price, right? And they sell the energy back. It's just another person that's selling it. We're just another person. We're a broker. We're bringing the 2 parties together, really, is what we're doing. We're like Uber. We're like Airbnb. We don't own any of the energy. We don't energy doesn't get transacted, right? I don't move the electrons. What I'm doing is participating and bringing 2 groups together with my technology, just like an ESCO or someone else would do, or the utility. So we're helping the utility. So we're an extension of the utility sometimes in that case. Did that clarify it?
It's getting there. So ultimately, what I'm hearing is the ISO and the utility will trust your numbers. They won't try to reconcile them or figure them out independently.
No, I think, yeah, well, I think that's a great question. Yeah, well, right now, right now it's voluntary trust, right? When you register your recs, it's all voluntary, right? You have to go in and say, yep, I sold those and I have these things. Because we're working with the utility and getting the meter data off the meter, that's where the trust comes in. But yeah, there is some implicit trust. Great question. I'm not sure I still answered, but I'll try that. Yeah. No, it's collaborative. It has to be collaborative, and that's why, right out front, you have to work with the utility. You can't replace the utility. People are trying, but there's no way we're going to do that. Other questions? Yeah.
Kind of a much more basic question about blockchain in general. It sounds like you're describing blockchain as a service that's provided by, say, millions of people around the world. So who's providing this service? How do they get into this business, quote unquote? And what's the incentive for them to do it?
So when it started when Satoshi Nakamoto started it in 2009, what happened in 2008? Right? So Greece, Italy, Venezuela, all these people are like, hey, we're not sure if we trust, we're having our money, the banks are closing, is my dollar worth $1, right? So he, she, them, we don't know who it is, got together and said, I'm not really trusting the government. I want to do transactions. I'm tired of paying $50. So one of my friends works for a Swedish company, right? He works in Boston, works for every week he has $50 taken out of his check from the Bank of Sweden to the Bank of America, which his wife is an executive vice president at, right? $50 every week. Why? So someone can transact, and the 6 middlemen in between can do that transaction and verify when you're getting a water stamp from a bank to a water stamp to a bank. People were like, this is crazy. Why do we have all these layers? Why can't we transact, you and I, if we agree on a certain principle? And that's what they were trying to do. So the idea is that, one, it's identity. Two, it's a different way of transaction, and people are seeing this as removing some steps. That's why you have the top 15 banks in the world actually doing blockchain, because they want to work with those middle people and the processes, and it's about business process that you're going to try to reduce the complexity. And that's why you have global supply chain companies coming together to reduce. This is like business process outsourcing, right? It's an if-then statement. The contracts are if-thens. If this, then do that. And you're trying to remove some of those barriers in those. And so when you ask, is it global, people want to be able to sell globally. People also want to be able to hide their identity, right? People want to know a land, that land in India, that land in Venezuela is mine. Today you have deeds that are a little squishy, right? But if I'm saying this is mine, or I'm saying that that diamond is really mine, it's not a blood diamond, and that's happening on blockchain, right? Because you can verify it where it's been made, you tag it. Those are the things that people are trying to sell and validate with the blockchain.
So there are, I guess, just citizens around the world
well,
that
so,
are running computers, that are running like software. Like I'm not sure.
Yeah. So okay. Yeah. So from a computer perspective, yeah. So Bitcoin runs on computers. There are so many Bitcoins. There are 586 million. That's all there is. That's all there ever will be. So when you do the mining and do the transaction, you get Bitcoin. If you want to buy a pizza for $6,020, whatever Bitcoin is today, then you buy the pizza for $6,020. 5 years ago, it was 25 cents. It was an internal economy allowing us to trade using a certain fiat currency that we knew. And that's one of the volatilities that people are nervous about, some cryptocurrency, because it's not worth $1, right? I have $1 today, and I know it's $1, and I can go somewhere and buy something for $1, unless I'm in Canada or Europe, right? Because it's not really $1 in Canada. It's not really $1 in Europe. So it's not the magnitude and scale, but that's still a problem. Why isn't my dollar $1? And so what happened is they did this through all computers. So in the Bitcoin process, it's all computer generated. There are no humans involved. You attach your computer, you sign in, and you become part of a node. So your computer is registered as 003. April's is 004. Melanie's is 005. Patrick's is 00900, right? Mine's 1. We're all global distributed. That's how it works. So it just pings and bounces back and forth. And that's the consensus mechanism. That's why it uses so much energy, because there are millions of computers doing it in that model. In the case of when you have 15 companies, the financial one, you have 15 companies doing it. Some may have 15 nodes, some may have 5, depending on the process. And so they're doing it. And as you add more data, you can only add so much data, like a database, to a node, to a block, and then for a block becomes a bunch of blocks and it becomes a node, right? So that's how that works. So those 15 computers, and multiple computers in that case, are all working together to do the consensus. Did that answer your question?
Yeah, sort of. Just one thing I didn't say is like, what do I get out of it if I'm providing a computer to the node?
So if you're doing the Bitcoin thing, you're getting Bitcoin if you get to solve the problem. If you're part of that community, you want to know that you have some transparency, or you're hiding your identity, or I'm locking my identity down. So if you're part of that community, you may want to know that, look, I just did my passport, right, renewed it. I had to go in with 5 pieces of paper. I'm sorry, I'm 57 years old. I have no idea where my Social Security card is because I don't keep it on me, right? Because you keep your social security card on you, God forbid someone will get into your system, right, and know your banking system, they can change it. Oh, by the way, I've had to change my credit card 4 times in the last year because of Wells Fargo, Blue Cross and Blue Shield, Target. What was the last one that just happened? So some people are doing it for different reasons. Some of it's for identity. A lot of people want to secure their identity and information. So some of it's pure money. Some of it is, I really don't trust the government, right? I don't trust the government with my identity. I don't trust the government with my information, my deeds, how much money I make, freedom of rights. So a lot of people getting persecuted, right, for what they say, right? But also some people want to track, if you think of royalties for musicians. So the musicians are all over this because now they can tag their information, their music. If you talk about artwork, how do you validate the artwork or things of that nature? So asset management is a very big thing, and people want proof that, you know, I own this and I sold this, or that is my land, that is my carbon credit, that is my diamond. So different use cases for different people. Does that help?
Yeah, and I don't want to monopolize time.
No.
And not all of them are positive.
And so one of the things to know about Bitcoin, right, is that it's a completely anonymous way to transmit, to do transactions, right? And it's pretty well known of some of the negative side effects of what's gone on in Silk Road and sort of some of the other forums, where if you want to traffic in arms, if you want to traffic in people, if you want to traffic in drugs, like a completely anonymous transaction process that's hard to fake is a pretty good way to do that.
Yeah.
There's other negative things to go.
Yeah,
with
there's
blockchain as well.
definitely. I agree.
You know, that's one of the flip sides of it. A lot of
Yeah,
it. Not to mention, as you mentioned before, some of the energy costs, depending on the way that the blockchain is structured, whether it's proof of work or consensus based, one will give you a much higher need of energy and compute power over time. So if you think about solving hard math problems and those math problems getting harder the longer the chain gets to verify, right? That takes up more compute power, it takes up more energy. And so the carbon footprint of certain types of blockchains will end up growing over time and accelerating over time, not just growing.
Yeah.
Only get more complicated as the blockchain gets larger.
Yeah, and as things start, I agree, there's a lot of nefarious stuff going on. The internet started, same thing. The number one for the internet was pornography, right? Guess what the number one? Same thing, you know. So no, there's some bad actors. And again, you know, telephones, all that stuff. I think, you know, I live the 80-20 rule, right? I'm hoping 80%, we're going this way, and 20% is doing the other, but it's technology, so you can do it for a lot of things. I'll go here and there. Yeah, go ahead.
Last 2 questions.
Yep.
His question, but for your blockchain,
Okay.
not Bitcoin. So, like, who are the other players involved, and what are they? Like, is it truly a decentralized system with a bunch of people, or is it centralized with you guys?
So me personally, or I'm sorry.
Your whole network. It says blockchain, CleanEnergyBlockchain network in there.
Yeah. So
I gather it's not people doing it for the same reasons as Bitcoin mining.
No. That's why up front I said we're not proof of work, because that's the first connotation. You guys are bad to the energy thing. You know, you're sucking up the world. You're a supercomputer and all that. So ours is it's a hybrid. We actually use part of Ethereum, the public, for transaction. They have the best transaction layer, and then ours is private behind permissible. So it's a community. So say Dartmouth, us, the Hanover Inn, and the Hanover Utility, Liberty, I think it is, right? If it was the 4 of us working together, that would be the transparency layer. So the 4 of us would have to do consensus. So the trust, and this is where you get into the supply chain. People go, but wait, I thought you were doing something else. You already trust your supply chain, right? So you already implicitly partner and trust. This is opening up that trust a little bit more to show some things. So ours is not a proof of work. Ours is a proof of authority, which means the authority of the 4, we can decide maybe it's 2 that approve it, maybe it's 4 that approve it. So that's ours. And it's SaaS model with AWS or IBM Cloud. So it's not a big lift. It's just the data behind it. Sorry, yeah?
So I believe, like, for anything to be a medium of payment, it has to have a kind of a stable value. how are you ensuring a stable cryptocurrency in your platform? Like,
Great.
what are the levers you're?
Yeah, great question. So why I introduced IBM Cloud is PowerLedger has their own token. They did an initial coin offering. So they have their own cryptocurrency. So they trade. When April and I are trading the energy back and forth, we trade what's called on Sparks. And it's tied to 1 cent in the US back and forth. And then you have to buy power, which is the tokens on top, encryption, a cryptocurrency that you buy on an exchange. So I put in X amount of dollars, I pay for power tokens, and then those, they have a 2-token system, which is going to create more chaos for you. But just say it had 1. You have to buy that. It's a network effect. They only have so many tokens out there. They have 10 million. Where we're going is some people don't want to deal with that. They want to trade dollar to dollar. One of the things, WorldWire is like a Visa trading platform that IBM's working with, that you can trade a cryptocurrency with a US dollar or a Canadian dollar to a US dollar. So the reason we're going there is for that. Some people do not want to do any of the trading on a cryptocurrency, but they want to do it on a local fiat currency. So that's how we're tagging it to whatever the dollar is, or the 1 cent if it's trading that, or the $1.
Are you doing it instantaneously? No.
Yeah. Every like 30 seconds, 1 minute, 15 minutes. It depends on how fast the data we get.
Right. Because if it's fiat to fiat, then you have the normal transaction time that you mentioned, which is not very efficient.
Yeah. And some people are like, hey, if it's 30 days or it's a monthly and we can get it to an hour, they're like, that's nirvana. If we get it a day, some of these people are like, wow, that's great. So yeah, the transaction is based on, some of it's where's the data, where to get the meter from, or the transaction layer. So great question.
On that note, let's thank Frank
Yeah.
for...
Thank you. Great question.